The topic is credit risk modeling for a bank, and the expert that we have today, he's truly an expert. Actually, his name is Mr. Anant Krishnamurthy. He's a PhD holder from Oklahoma State University, one of my state rival, one of my university's rival universities. So Anant has altogether 17 plus years of experience in various machine learning, uh, optimization, analytics, data science related topics, and he has a variety of functional expertise ranging from, again, as I said, deep learning all the way to optimization to simulation modeling. And he has worked with variety of companies as well. Some of the Indian MNCs, Indian giants like Tata Steel, to to some of the global giants like AT&T, Halliburton, Rico Americas, and so on and so forth. So it's really a pleasure, Anand, to have you today, to to listen from you, and I'm sure the young crowd that we have today will
Yeah,
gain quite a bit from your experience today. So, guys, only one rule about the questions: no question is a bad question, guys. However, please type in the question, instead of asking the question. Unless until the end of the seminar, until the end of the webinar. Once the topic is over, then we'll open the ground again for question and answer. But in the middle, if you have any question, feel free to type in your question. That'd be great. Thanks a lot, guys. Hey, Anant, all yours.
Thank you, Pratik. And Pratik, thanks very much for the kind words and the really good introduction. Thank you again. So here are the logistics for this meeting. Again, it's short. We have a lot of content. We've tried to organize it in such a way that we can get through most of it. But as Pratik suggested, during the presentation, if you have some questions, please type them in. We'll have about 15-20 minutes after we are through the presentation to take your questions live. So with that said, let's jump into it. And if you guys are having any audio or video problems, please type that in as well, and we'll try to help you offline as much as we can. Unless anybody is going to speak up, I'm assuming we're all good to go, and I'm going to proceed. All good?
Yes, please. Yes, Anand.
Okay. All right. And you're able to see, Pratik, I'm going to use you as my mirror here. So
Absolutely.
you are able to see the.
Absolutely.
Okay.
Absolutely.
Okay. So very quickly, we've got slides, we've got a notebook, a demo per se. So we'll spend about 15 minutes getting through the slides, and that kind of sets the context for what we are going to look at in terms of models and code and things like that. So that's 15 minutes. 30 minutes we'll spend on the actual modeling activity
Anand,
in
share,
Jupyter Notebook.
can you share your decks? Can you share your PowerPoint? Because I can see the browser can't see the PowerPoint. The slide.
It's actually, I'm on the PowerPoint, so I don't know what. Let me try this again. It says sharing, but these things are always interesting.
Yeah.
Just a second. Sharing your screen. Okay, and stop sharing, and then I'll try this again. This is entire screen. All right. Is that working now?
Give me just 1 second. No, it's not working. Just give me 1 second. Let me. Because why is it not working? I tell you, because it says you are offline, but we can hear you. Which is a
Okay.
pretty funny thing.
Yeah.
So I'm not sure how we are able to hear you. You're using the only one connection. Now try it. Now try it. It says you're presenter again. Try it again. Unshare and share again. Um, so Anand, just can you hear me, Anand? Hey guys, just give us a couple of more minutes, okay? I'm bringing the presenter in again, okay? We just had some technical issue. Just give us a couple of minutes.
Here, okay.
Anand, can you hear me, Anand?
Yeah, Pratik, I can hear you.
Okay. I am going to make you the
All right. So
presenter. Anand, go ahead and share your screen now, please.
you see the second page now, what we will discuss.
Yes, we can see now. So there is a little bit of lag, okay? Just like couple of seconds lag, but just go a little slow when you change the slide only. Audio is completely
Sure,
fine.
I'll. Great, great. That's usually the more difficult piece. All right, guys. Sorry about the small technical glitch. Hopefully, we should be fine going forward. So, here is what we will discuss, right? So, we'll talk about credit risk modeling, and we'll do that through using real world data. So, what I want to give you a flavor of is, I don't want to work on a toy problem. I think you guys have seen this in many, blogs and training sessions. The idea of this presentation is to kind of give you a flavor of what this looks like in real life. This is slightly larger data set than you may see out there. So that's one aspect of this presentation. The other is to look at machine learning. So I don't know how many of you are currently familiar with analytics, doing analytics in your job, or maybe advanced users of machine learning and analytics and so on. So this is intended to be kind of a introductory course, but we are not going to be looking at the concept level. We'll dip into code and we'll look at how these things are done. The idea is not to overwhelm you; it's to give you an idea of the level of detail and the amount of understanding and training you need to be good at this. So yes, I mean, we could have chosen a very graphical tool. We've chosen Python instead. That's usually the way. Python and R are the two tools that people commonly use. So we'll go with Python. We could have gone with R as well, so it doesn't matter. But both of them are code, primarily code. They're not graphical user interfaces, and initially it's a little daunting, but you will eventually get used to it, and it's very powerful once that happens. Okay, I will move to the next slide now. I think Pratik's already done a good introduction about me, so really don't want to add a whole lot here, except that we do a lot of mathematical modeling. Machine learning happens to be one of those areas that we work in. Okay. Okay, so intended audience for this presentation, again, I don't assume that you know anything about machine learning or banking or finance or anything. I mean, this is an introductory lecture, as introductory can get. It does involve detail, but it is an introductory lecture. So we don't assume any background in machine learning or credit risk modeling or what have you. And we also assume that you want to understand in some level of detail how these models are built and so on. So if you're looking at something at a very introductory high level, then the slide deck, the first 15 minutes will be useful for you, but beyond that, we will get into some level of detail. Okay. With that, I will move on to the next slide. And Pratik or Tarit, if there are any questions, please let me know. Otherwise, I'll continue assuming there is, everything's fine.
Sure.
Okay, all right. Okay, so credit scoring. The idea of credit scoring is very simple. So a lot of times when we hear finance terms or banking terms, we get daunted. But credit scoring is really simple. Credit scoring or scoring, really, the word scoring is used in many areas. Credit scoring is just one of them. But when someone says scoring, it means that you're going to get a score. You're going to give a score. Okay. So credit scoring is the act of giving a credit score to an individual. Okay. So why should we do that, right? So the questions banks and other financial organizations, fintechs, apps, whatever you can think of. The question they're asking is, should I give this guy a loan, right? Him or her or whatever. Will he or she default and not pay back the money I've loaned that person? And let's get even more specific than that, right? What's the chance of that happening? So a score should tell you, should answer these questions. So you can think of different kinds of scores, right? A score can be a 0-1, 0 meaning he's good loan, and 1 meaning a bad loan. or it can be a score of 0 to 100 or 0 to 800 or whatever what have you. Different companies have different scales, but um, it's such we need to understand that usually when we talk about score, a higher score means that you have better credit. So 100 out of 100, okay, give him credit. 0 out of 100, well, this guy is sure to take your money and run away. Okay. And then the last question is why use machine learning? We've done well all these years for 400-500 years without using this. Well, what's the benefit of using machine learning? And the answer really is, we'll come to this in a second, but the answer is machine learning is far more effective and efficient than doing it the human way. So that's really the short answer, and we'll talk about this in some more detail. Going to the next slide, let's talk about the context for our demo or our walkthrough. So we're going to talk about Lending Club Corporation. Lending Club is not exactly a bank, but it's a financial institution. It makes loans. So it's a peer-to-peer lending company, and it's quite large. I mean, if you look at its revenues, $213 million in 2014. They basically lend. They collect money on one side and lend it to people on the other. So it's a P2P lending platform. But for the purposes of this exercise, they are in the business of making loans, and when you're in the business of making loans, and they're making loans to individuals, and then it's not companies, it's individuals. So they need to know, again, the same question: is this guy going to return my money, or is he going to run away with my money? Is he going to default? Okay, and the reason you need a score is it's not a 0-1 case always, right? Sometimes you may want to take, as a bank or as a lender, you may want to take more risk, so you may want to give money to people with lower score and maybe charge them more interest for it. So a score is useful if you have a scale instead of a 0-1. Okay. All right. So what are the tools that we are going to talk about, right? So a lot of us, including me, we don't like code. We find code to be intimidating. But if you're in analytics and machine learning, then you have to get your hands into writing code. Now, most of the code you write will not be like the code that developers write. It's not what I would call as programs. I mean, they are programs, but the more technically appropriate term for it is a script. So Python is a very popular programming language, which is very English-like, so it's very easy to learn relatively. PyData is the name that we give to all the libraries that the open source community has built in Python for data science. And prominently, the ones that we want to talk about today are Pandas, scikit-learn, and matplotlib. Okay, so again, Pandas is you can think of Pandas as a very complicated or very sophisticated. I don't think complicated is the right word, but sophisticated pivot table kind of utility. It's not graphical, but it's a very sophisticated pivot table utility that lets you slice and dice your data in various ways, and then we'll look at that. Scikit-learn is the name for the Python, the prominent Python machine learning library that people use. 90% of data scientists who use Python will use scikit-learn. And matplotlib is a very popular library for making plots. And then, as I asked this question, many years back, why do we want to use open source, right? Why not use something from Microsoft or something from SAS or something else which is commercial? The real answer is it's a one sentence, right? It's just better. So open source software today is a lot better than many, at least when it comes to data science libraries. It's a lot better than what you get with commercial tools as well. And I've lived through this. So I started my training in data science with SAS. I moved to R, and eventually I moved to Python. So I kind of, when I say this, it's not a theoretical thing. We've experienced some ups and downs of using commercial software. There was one case where we were working with a technology that got purchased by Apple, and they decided not to sell their software anymore. So we lost about 8 months, or we took another 8 months to retrain on something new, and that something new we decided would be open source, and we will never get into that trap again. So, and again, simple economics, SaaS costs 11 lakh rupees a seat. Python is free. Very easy choice to make, according to me. You don't give up anything. In fact, you get more. So it's just, the people who learned technologies like SAS wanting to stick to SAS, and the newer generation wanting to move to Python. So, or R or whatever, what have you. So, that said, I'll move to the next slide. Quick check, Pratik, are we doing okay so far?
Yes, absolutely, Anand. Absolutely.
Okay, thank you. All right, so why do this at all, right? We talked about machine learning for scoring, right? So now we're talking about an activity in credit scoring. So why don't we just have experts do this for us? Okay, so first of all, manual scoring. Manual scoring versus machine scoring. Right? Manual scoring means you have an expert that looks at an application and says, yeah, this is good or this is bad, or this guy got 68 out of 100 on credit score. So manual scoring is person or expert dependent. It's not always bad, but if you think of, let's say you're a startup company, you're a fintech company, can you really afford to hire a 20-year veteran and who's got experience with credit risk? And if you have 1,000 fintech companies like we seem to have in India, how do we scale this, right? But that's only a small reason. Manual scoring means that the human brain is processing all the information, and it can go out of sync with the market fast. Meaning, let's say that you have an economic event. Let's say that for whatever reason, Chennai is not doing economically well. You will see that in the data much faster than an expert can detect it. Okay, so manual scoring can get out of sync with market very fast. And this is especially true in new and fast-growing markets, right? So in a new market, the expertise of an expert may not be readily transferable, whereas data may speak louder. And especially when there is fast-growing markets, you need something. An expert can score 10 applications a day, 100 applications a day, 1,000 applications a day. What if you're doing 10,000 applications a day? And it's not manually scalable to do this. Okay, so the idea of intelligent scoring using machine learning, and I'll use this abbreviation ML for machine learning. Intelligent scoring is data dependent, and so it's usually more accurate. Not always, but it's usually more accurate than human judgment. Again, the idea is simple, right? A human, through experience, can hold so many things in his brain. Machine learning algorithm can process huge amounts of data. Millions of records is nothing, right? So in an activity like credit scoring, it does have an advantage. There are many tasks when the human brain is far superior. For example, things like image recognition and things like that. Even there, the boundary is fast disappearing. But especially when it comes to a task like credit scoring, it's an algorithm will beat a human expert in most cases. Also, algorithms are always running. They're in sync with the latest data. They can find out micro patterns. So let's say that there is you need to give a different set of credit scores to MNC workers in Pune that came out of that have a engineering degree. Yeah, the machine learning algorithm is ideally suited to do this, but it's very difficult for a human to pull these things out and pull these things out fast, right? So algorithms and machines don't need rest. They're always working, so they can always detect these patterns. It is true they can always also go wrong, but if they are well crafted and properly tended to, then they can be very, very advantageous. Okay. Some of this, I mean, most of this is stating the obvious, but I just want to make sure all of us have the same context as we go into the walkthrough. All right. Moving to the next slide. So the steps involved in building a usable machine learning model, and getting it to use is really the same across any kind of machine learning model at a high level, right? So whether you're talking about an AI model, a traditional regression model, a deep learning model, there are these three steps that are always common. The first is you have to prepare your data, and this usually takes up about 60 to 70% of the entire effort. Data it's not only cleaning the data, but also structuring the data. So data is getting better and better with time, but also the volume of data is increasing. So we've got challenges of different sorts. So once you prepare the data, then you would train a machine learning model. And we shouldn't complicate this in our head, right? A machine learning model is a formula. You should just think of it as a formula. So given some inputs x1, x2, x3, a machine learning model is a function that says y is a function of x1, x2, x3. That's all it is. It could be a very simple function like y is equal to x1 plus x2 plus x3, or it could be a very complicated transformation involving not 3 but 30,000 variables. But a machine learning model is just a function. Okay, it's a function where we don't understand what the form of the function is. So training a machine learning model is the act of looking at data and figuring out what that function is without someone telling you that, hey, this function is x1 plus x2 plus x3. Okay, so that's training. Testing is to see how good that function is that you come up with. So the idea is we'll build many models and we'll pick the best model. It's very, kind of sounds intuitive, right? Okay, so we've done data preparation. We've used the data to train the model. We've tested the model. We have a good model. The last step is to put this model to use. So if you're a bank, you want to get this model into the hands of people who are making the credit scoring decision. Better yet, you may want to write this model into the application, like a loan origination application or loan processing application that your bank is using, so that the people doing the loans, making the loan decision don't even notice this. It's in the background. At the step when they are going to make a decision, it says, oh, here is what the machine learning model is predicting. The answer is this guy's credit score is 78 out of 100. Okay, well, and then you can either have a manual step there that basically has the authority to override the decision, or as in case of many fintech companies, this is an automated decision. There is no human involved. The model gives the decision to approve or not. Okay, so 3 steps: prepare, train and test, deploy. All right.
One quick question is there, Anand, by Manoj. He's asked this question, and I'll quote him. Can we get functional form in the final model selected using any machine learning algorithm?
Good question. The answer is yes. There are 2 ways to do it. One is, depending on the model that you use, the functional form will be revealed. For example, if you use a regression model, the model is trying to fit an expression, so it will give you the equation at the end of fitting this model. Another case may be where you use a computational model which does not have a functional form, a closed form solution, as we call it. So it's not a function that can be expressed in terms of polynomials or exponentials or any combinations of those the regularly known functions, mathematical functions. A common example of that would be a decision tree model. So what people do in that case is they build what is called as a surrogate model. They somehow try to approximate the workings of the decision of a computational model using by force fitting it to a regression model. It's not very useful, but people do want some kind of a functional form. So you may, so if you want a functional form, use a model that has a functional form within it. Typically, why people would go to a model that doesn't have functional form in it is because it's more accurate. So if you look at things like random trees, they're going to be much more accurate than in many cases with a lot of data than regression models. So let me summarize my answer without confusing you. The answer is yes, you can get a functional form if you use a model that uses a functional form inside of it. However, there may be other models that are more accurate than a model with a closed loop functional form. So Manoj, I hope that answers your question for now, and if you have more follow-up, we can take it up after the Okay. All right, so here is the notebook walkthrough. I'm going to just give you a preview, and then we will step into the notebook itself, right? Before I get into this, so a notebook, we're not talking about a physical notebook, right? We're talking about the software called Jupyter Notebook. It's a very nice interface to so that people like you and me can write code without getting overwhelmed by the code. So it's a nice way to just step through code in single sentences. So on this slide, prepare data. If you look at this line in gray, current loans, something, right? This is just one line of code. So we don't need to compile it. We don't need to do anything. Just type that one line, enter, and then it'll give you the result of that. So a Jupyter Notebook is a very interactive interface where you can put
Anand, can I ask you to zoom the slides to 100% if possible?
Oh yeah. I can do it full screen, or I can. That any better? Anyway, we'll get into this in more detail. Yeah, we will step into this with a lot more detail.
Sure.
So don't worry if you're not able to get the, we will get into this. So again, so let's review our steps, right? So the first step is to prepare data. So in our case, we have raw data from this Lending Club Corporation on loans that they've been kind enough to share this data with the world. It has about 4.6 lakh records with 68 columns, or I think 70 columns or something like that. And there may be values that are missing or null values. Some may have format issues and all that. So obviously, if someone is giving you data, whether that's an external party or an internal party, even if it is coming from your own IT or a database guy in your IT department, you cannot in any reality, you cannot expect it to be 100% clean, because it's not that the person may be negligent, it's just that they don't understand what you're going to do with the data. So usually they'll give you the best data that they can. It'll still have missing and null values, and it's up to you to clean it up. So 3 steps again inside this. So as you prepare the data, extract the data. So it may be in a database, it may be in a text file, it may be in a JSON file, it doesn't matter. Extract the data, pull it into a place, pull it into either Excel or Jupyter Notebook or whatever, and then first understand it, right? Don't start building a model. First, try to understand what the data says. I mean, is this really reasonable data, or this is just horrible data, right? So if the data is bad, stop, go back and understand whether the problem is with the data or that you don't even have data. So some of these startups, fintech startups that we work with, they don't have any data. They let's say they make 12-month loans and they've been in business for 8 months. Even if they made a loan on day 1, they won't know whether. So they can tell me that I made so many loans, but they cannot tell me whether this loan was paid off in full, if it was abandoned, if it was repaid, if the customer returned the money, they don't have an outcome. So understanding data is much, much more important before you get into building the model. So once you understand the data, then you know what to keep and what to drop. So if you start out with, let's talk about a number, right? Let's say you start with, 4 lakh records. You don't need 4 lakh records to build a good model. Most likely what you will end up doing is take a small subset of that, a subset that is very meaningful, and build your model on that, and that will really, really, go a long way in getting you a good usable model. If you don't do that effort, first of all, most likely you will be unsuccessful in building a credible model. But even if you do, it may not be accurate enough. Okay. So we'll step through this whole process in live code. On the next step, right? So train and test. So building a machine learning model once the data processing is done is incredibly easy. So and all these things come with a caveat, right? So you should know what you're doing. It's like saying, firing a gun is very easy. So if you don't know what you're doing, you may injure or kill someone. But really, the heart of this entire machine learning model in this exercise is just these 2 lines. Okay. But if you just know only those 2 lines, you can't do anything. But yeah, so we have to build a model. We have to understand how the model performs using some kind of statistics. And that's both training and testing, right? So just because you built a model doesn't mean it's useful. So how will you know if it's useful? You have to test it and get some idea of how it's performing. If the performance is acceptable, then which is deploying the model. So again, score, you want to assign a score for new applicants. So that's the whole idea of building a credit model is not to assign scores to the people that have already taken a loan from you. That does not make any sense, right? They've taken a loan, they've either paid or defaulted on that loan. That life cycle of that loan is over. Scoring is only useful if you can get new applications and then put a score on them before you give them a loan, right? Otherwise, this is completely useless. So you have to think about what data will I have when a new applicant comes to me, and only use that data when you try to build a model. And as we go through this, it'll become apparent to you. Okay. And then, as I said, once you have that model, you'll deploy it as a function so that other applications can call it. It could be as simple as, using it in a spreadsheet. It could be as complicated as writing a web service and deploying it so that other applications can call it. Doesn't matter. But the idea is it should get used by someone other than the guy building the model. Okay. And then that's not the only use that you can put a model to. A model can also be used for additional analysis. Like you can use the model to build multiple scenarios, right? What if I take some more risk? Is that good for me? Is my yield going to increase? Is it going to decrease? Should I shed some of my risky portfolio? Should I add some risky elements to my portfolio? So these are all things that you can do with a model that typically people don't consider, but yes, that's a very powerful use of the model. All right, so this is what we are going to now step through, and before we do that, and as I pull up my system, I want to see, Pratik, if there are any other questions that we should take or anything that we should change before we get into.
So one question was, why do we what is the need of a validation? Why don't we create the model on the entire population? So I can answer that question, that if you create the model on the entire population, where will you test it?
Right. But it's a good question, Pratik. It's a question that I used to struggle with, right? So people don't explain this very well, and I have a really good down-to-earth explanation that at least makes a lot of sense to me. So I'll try this. Okay. Let's say that as a kid, right? There's a kid that's practicing to take an exam. I tell this kid, here are the 100 questions that are going to come on this exam. Okay, the entire exam, you'll get 10 questions, but it's always going to come only from these 100 questions, and here are the answers. So this kid is going to probably just memorize all these 100 questions. We call this mugging, right? We just mug the question and the answer. Now, as long as the question comes out of these 100 questions, the kid will always answer this 100% correct. And we call this mugging. And what mugging means, and we all can relate to this, right? Mugging means no learning has happened. You've not understood the concept. You only, if someone asks, what is the color of apple? You just mechanically repeat the word red. That's it. You don't know. You haven't put any more thought into it than that, right? Now, if the kid gets a question outside of these 100 questions, and he is still able to answer it, now that is when we say that the kid has learned, or in our case, the machine has learned. So that is why we want to have a separate validation set or a test set. And then, data scientists are guilty of this, using so many terminologies that nobody can understand this. So it's
excellent answer. Excellent analogy. Okay.
So the easiest way to think of this is, I'm going to teach this kid a lot of concepts, fine. But when I actually give him a test, I'm going to ask him things that, well, the answer is found in what he has learned, but it's not a simple, mugging exercise. He's actually should have learned something. He should have extracted a functional form out of data. It's not saying, well, if a house price is how a square footage of the house is 1,200 square feet, then the answer is 68 lakhs. That's mugging, right? Hopefully, if he has learned something, then there is actual, and that's what we're trying to do. We're trying to teach machines to learn, not store data.
That's right.
So we'll see that. There are some examples here. Can everyone see my screen with some,
yes.
It says credit scoring using machine learning? Okay. What I've done, I've taken the liberty of just running the first couple of lines, because these take a little bit of time. So the data set we have is,
just zoom a little bit, Anand. Just a little bit.
I can do that. Yeah. Take off some of these. All right. Is that any better?
Did you press Control Plus? I didn't see anything.
Yeah. Just wait for a second.
Better.
Okay. All right. Okay. So, all right. So this is huge. Okay. So. I think we're running a little late on time, right? Okay, I'll pull my socks up on this. Okay, so let's look at the credit data set, right? So we are going to take a look at this data set and look at the size of that. This is not small. This is 248 MB, okay? A quarter of a gigabyte, right? So we're not talking about a small data set. You can open it in Excel. Excel will cry, but it'll open. I mean, you can do it. But what we do, the way we do this in Jupyter. So this screen that you see is Jupyter, if you're not familiar with it. This is a place where you can write single sentences of code or multiple sentences of code, and it'll immediately give you an answer. So I don't want to overwhelm you with code. Again, you guys should, this is not what you should take away from it, right? You should not get overwhelmed with code. It's something that you will eventually learn. What you should understand is, here is a tool that you can pay 10 lakh bucks and you can get it, but it's free, okay? It does require you to learn, but it is literally a first-class tool that you can get simply by downloading it. And also, a majority of data science people worldwide will use a tool like this. I'll go out on a limb and say we'll be using Jupyter Notebooks. So Jupyter Notebooks are used with Python, they're used with R, so they're very, very popular. Okay, so here is a data file that we have, loans.csv, and it takes about a minute to load, so I didn't want to make you guys wait. So this first step basically imports these two libraries, Pandas and NumPy. Pandas is the library that we can use to read a text file. It can connect to anything from as simple as a text file to something like a HDFS cluster. So it's quite powerful. By running this line number 3, look at what we are saying. Once you get used to reading this code, initially it kind of sounds, a little hard to understand, but this says pandas.read CSV file, name of the file. So this is the name of the location, and we basically can give some extra instructions to it. In this case, if there is a date time format, try to infer it. Now, just because you said that, it may or may not be successful, but yeah, that's fine. Okay, so in a single line, it's taken about a minute. It'll pull out that loans.csv into memory, and let's try and do our first step. Let's understand the data. So loans is the table in which our data now resides, and we'll execute this very simple statement, loans.dtype, so data types, and it will list me all the data types, for every single column in that table, in the loan table. Okay, so you can see that there are some columns that are integers, some columns that are objects, and usually object means a string. Interest rate is a float. Okay, so is it an integer, is it a float, is it an object? Fine, so these are kind of things that you have to do. So one of the things that I want you guys to understand or think about is this, the way I'm showing this is very linear. It kind of may give you the wrong impression that, oh, this guy started typing it out and it came out in this in this nice sequence. So it's like saying an author started writing a book and he wrote it chapter after chapter after chapter until he was done. It doesn't work that way, right? There's a lot of iterations. So and you only do the steps that you are interested in. So for example, loans.shape. Shape is the shape of the table. It'll tell me how big the table is, not in bytes and megabytes and things like that, but how many rows and how many columns, right? So 4.6 lakh rows and 68 columns. And if I want to just take a peek at this, so one of the things you don't want to do is you don't want to see 4.6 lakh rows, right? It's useless. So just to get a sense of this, you can just look at the first five rows of this. So it'll give you a glimpse of it. Now, if you truly want to do this, you'll have to print out every single line, but it'll tell you, okay, here is what it looks like. Now it has to fit 68 in here, right? So it may not, for something in middle, it may just do ... So it's just to give you a sense of this. It's not a comprehensive thing. If you want to make it comprehensive, you can print out this entire table, and you can do a lot of other things. This is just to get a sense of, did the data come in okay? Did it get corrupted? So on and so forth. Okay. Quick check, Pratik. We're still doing okay?
Yeah, just remember there is a 1 second lag, okay? When you refresh,
all right.
when you go down, yeah. If you want, you can zoom out a little bit. That's fine, but just remember there is just one.
Hello.
Yeah, just 1.5 second. That lag is there. Just remember that. Yeah. Thank
you. I'll keep that in mind. Thank you. All right. So remember that in any real-world data set, right? Again, as I said, nobody's going to give you fully clean data for your purposes, right? So let's look at, we told Pandas, try to make sense of all the date time columns. May or may not happen. So these are the date time columns that I saw in those columns. I'm going to just take a look at only these columns. I don't want to look at all 78 or 68 columns. I just want to look at about 10 lines at random, or the first 10 lines rather, for only these columns, okay? So I expect a date. So these are, like an issue date, final date, last credit pull date, whatever. But these don't look like dates to me, right? These look like something that should be in a database, but these don't look like dates that I can work with. The other thing that I notice is that I have values like NaN, which means not a number, could stand for missing data, it could stand for something funny that Pandas did not consider a date and just threw it out. So we have some work to do, right? So data will not be perfect to start with, but you can get it in shape very quickly. Okay, and you can take a look at what is the data type for these columns. So it'll basically tell you that most of these seem to be strings. Don't worry about the code, but what we can do very quickly is we can fix that. This code is going to take about a minute to run. It's a little it does take some time. But what I'm going to do is I'm going to take only two columns: issue date and the column that today or right now says issue underscore D. I'm going to create a new column called issue underscore date and make sure that whatever was stored in there as a string will get properly converted to a date and get stored there. Okay, and the reason and the question is, why do I want to do this, right? Whenever you have things like date or integer or float values stored as strings, what can happen is you may get to a step where you may ask a very simple question: tell me all the loans that were given in 2012, and Pandas or any processing system will say, I don't know how to answer that question because you don't have dates here, you have strings. So the first step is get data converted. So some of you might have run into this with Excel also, right? So you see data in Excel and you think it's an integer, but it's actually a string. So in the interest of time, I'll try to move to a saved copy that I have. Okay, unless our guy came up with something. Okay, so all right, so that operation takes about a minute and 23 seconds. When now, if you look at those two new columns that you created, right? So it used to look like this: issue underscore D and final underscore D. But now what you have is a nice column that issue date, which actually looks like a date. Now, is it really a date? That we need to figure out. Is it? So if we run D types again on this table, it'll tell you that here are the two columns that you created, and now they're not strings, they're date time, and then we'll use that in the future. Okay, so yeah, this guy's still running. I'm going to switch to the previously used the previously executed notebook rather. All right, so why did I do this, right? Was all this useful? Here is an application, right? So I want to know all those loans. I want to flag all those loans where the loan was considered to be, the term of the loan has finished. Okay, so in case of Lending Club, they consider any loan with, and this relates to when we pull the data, right? So any loan where the final date was before March 2015, those loans are considered to be loans where we know the outcome of it one way or another. Okay, unless we created a formatted column with unless we created a formatted column of final date, we couldn't have done this, right? We cannot run this kind of an operation on string data. Okay, so we will go ahead. I'm going to, in the interest of time, right, I'm going to go a little fast if you guys don't mind, so that we have some some time for questions.
Sure.
All right, so so now we can see, okay, so dates which are below 2015 March, with the final dates below 2015 March, they're we have put a flag of true on the outcome, and if they are after 2015 March, we've called it false. Okay, and we'll see how that helps us, right? So we'll get there. The other thing you may want to look at is, so okay, you have a lot of data. Okay, so you may want, before you get into any modeling, you may want to say, what does my portfolio look like? I mean, what's the status of my portfolio? So what you can very easily do is do a group by operation. So you can say, Now that I have the column outcome, the flag of true and false, show me, how many of them are outcome true and outcome false. So let's
Anand,
see if
can
this
I
guy
can
is
I can
executed.
I interrupt you for a second? I
Yeah,
think we can't.
yeah, yeah.
Our screen is frozen to the last. I mean, so what we see is loans date column plus new column dot d type. That's where we are frozen.
Hmm.
And funnily enough, it says that you're offline, which is
Again, huh?
surprising.
Should I do a stop sharing and then you
Yeah, yeah.
enable sharing again?
Sure, sure, sure.
Okay.
Can you try to share again?
Um, yeah, let me. I think if it's better if you take me off presenter and give me presenter again, because I
Sure,
think, yeah, otherwise it goes a little cranky.
sure, no problem. Do you want to re-log in quickly, Anand?
Okay, let me just try this once before we do that. Yeah, just a second. I think it'll need a relogin, right? I'm going to
Yeah,
exit. Is that
yeah,
okay?
yeah, yeah. Guys, just hold on for a second. Anant is re-logging. All right, Anant, I think you're logged in. I made you the presenter. Please start. We can see your screen. Can you share the deck? Or, sorry, Jupyter?
All right. Are you able to see it now?
Not yet.
Okay.
Have you switched to Jupyter, Anand?
I did. I don't know why it's not showing for you. It says sharing.
Okay.
Um,
Okay, now we can see
Interesting.
the screen.
Oh, you can see the Jupyter screen?
Yeah, yeah. Now we can. Go
Okay,
back.
all right. Okay. I
Yeah,
think it's going to switch back and forth. There is a lag. I
that's
just
fine.
need to be patient.
I can
Sorry
see
about that.
we can see the screen.
Okay. All right. All right. So let me know when you can see portfolio status on the screen.
We can portfolio status. We can see.
All right, all right. So, a couple of quick group buys, and I don't want to spend a whole lot of time on this, but um, having a tool like this, you're in a meeting, your boss asks you some questions. You don't need to go with a static report. You can crank out. Imagine, I'm handling 250 MB of data, and I can answer any question that you throw at me. Just slice and dice the data. It's not an Excel pivot. It's very, very fast. Okay, it's all in memory. It's not going to. If it loads, then it'll give you. I mean, and memory is cheap, right? So if you get. Um, what I'm going to do in the interest of time, right? I'm going to get to the model building part. So. Let's look at loans where all the activity is seized, right? So this is the part about where you take your data and zero down on the data that's relevant to you. So just because you have 4.6 lakh records doesn't mean you can build a model with 4.6 lakh records, right? So let's look at inactive loans, okay? So we have loans, we have about one out of the 4.6, 4.7 lakhs, only 1.2 loans are inactive. Inactive means they were either paid off or they're defaulted on, but it's done. It's closed one way or another. And if you look at them by outcome and then by inactive loans. So outcome means the term is ended. So let's look at. So what we're trying to do is we're trying to take the entire data set and subset to that piece of data, which will help us build a model, right? What are we trying to build a model on? We're trying to say, given data, can I build a model for predicting credit score? So one of the requirements is that you should only build a model on data where the term of the loan is ended. You don't want to include in this model loans where the term is the loan is still in progress, right? So outcome should be true, and then you want it for inactive loans. So you could still have a loan which the term ended in March 2015, but somehow the guy was not able to pay it. But he's not willing to call himself a defaulter. He's trying to pay, slowly. It's been 3 years, but he's still paying. You don't want to keep that loan. So you want loans that the term is ended, which is outcome is true, and you want the loan to be inactive, meaning it's been dispositioned one way or another. It's been said that, okay, this is a good loan or it's a bad loan. Okay, and that's what we are going to do. So I'm going to skip some of this current loan stuff. We can look at current loans and what have you, but what we will do, we will get into building the credit scoring model. Okay, remember that you may have 70 columns of data. You don't want to start building a model with all 70 columns. You'll get nowhere. So the best practice is to start small. Maybe start with 3, 4, 5 variables, 10 variables. So we're taking a few variables. And how do you select this? This is just business experience. It could just be a random starting point if you don't understand business, but start somewhere, right? Don't start with 70, start with 10, 15, something like that. So features are your X variables. Features are what are inputs to help you understand whether you can whether you can call this a bad loan or not, and the response is what we call as a response is the column that indicates whether it's a bad loan or not. In this case, we have a column called bad loans. Okay, it's very important that you don't put the response as a feature. Okay, people do that and suddenly they'll get a 100% accurate model. If your model accuracy is very high, it means that you have something in there which shouldn't be in there, right? So if you tell the model, predict what's a bad loan, and one of the inputs is it's a bad loan, that's just stupid, right? So, all right. So let's just so these are the features and the responses. Let's get a proper subset of loans. So we'll take loans that are outcome is 1 and inactive is 1. We just talked about this. The reason I'm stepping through all this, right, is to give you a sense of how quick this is in Pandas as well, or Jupyter rather, right? Okay, so I may have some missing values. A very simple way to take care of this is use this command drop NA. And if you're wondering, where do all these commands come from? This tool has been written by data scientists. So they've built all these functions. I mean, it's a lazy man's tool. Once you learn that, you have a lot of functions to help you. You don't have to write a lot of code, and that's why I call it a script. It's not a code. It's just to check, are we all able to see this? Let's get a proper subset of loans title.
Yes.
On the screen.
Yes. Yes.
All right. Okay. Okay. So completed loans. We will go from completed loans to clean loans. I want to drop all the missing values. You got to be careful. If half of your values are missing values, then you can't just drop it. But in our case, we'll see that. What I started out with completed loans was 36,849 loans. But if I drop all the missing values, missing value means there is a missing value in at least one of the columns, one of the X columns, right? I'm losing only 29, so that's really good. So yeah, that's fine. I'm going to keep clean data as the table that I'm going to go forward with. So loans dot drop NA. That's it, right? Okay. All right. So here is a part that we don't want to get into right now. There's a lot of code on the ML side, but all it does is import some libraries, build some subsets, does some mapping. It's not really relevant to what we're doing. So I'll just let this run for a second, but all it's doing is importing some libraries and mapping some data. So it's not terribly important for this stage of our discussion. What it will do is it will take the clean data set that we have, and it will give us an array of X and Y values. Okay, so there is some amount of learning that goes into doing something like this. In hindsight, it's simple, but you do have to learn this a little bit. So let's scroll to that point, and I think you guys are probably thinking what I'm doing, but let's scroll to the point where this is completed, right? And let me see. I apologize for switching between screens. Okay, it's done on the screen that we were. So what we get now are X and Y values. X is your input. So one of the good things about data scientists is they like to think of everything as Y is equal to F of X. So let's keep it that way, right? So the inputs are, I have 36,820 rows and 38 columns of data. Why 38? Because I'm not taking all of them, and I'm doing things like one-hot encoding. Again, let's not get into all these details, but sometimes when I have a column that is categorical, let's say a term is 36 months or 60 months, machine learning models cannot directly handle that kind of data. So we usually represent it by two columns of ones and zeros. So that's why we may have started out with 15 columns and now we have 38 columns, but ignore all these. We still have X and Y. That's all you should remember. So here is a good part, right? Someone asked a question about validation. That's what we are trying to do here. So we will take this data of X and Y and we will split it. We'll keep 20% for testing and the rest for training. So again, look at this sentence, right? You don't have to write code. This is just a script. Once you know this, in one single sentence, you say, take X and Y and split it into X training, Y training, X testing, Y testing. And that's all it is. And it takes, it's super fast. It does that. So here is the famed machine learning model that we're going to build, right? So people think that machine learning is very, very difficult. It's just these two lines are essentially the heart of machine learning. That, in my opinion, these are the only truly machine learning pieces in this model. So we are going to build a logistic regression model, okay? And we are going to fit the model with the training data. So X train and Y train, and it's done, okay? It's gone through 38,000 or 30,000 data points. It's fit a model. So, if someone says my model is built, yeah, we've got a model here, right? Now the question is it any good? Is it useful, or is it completely, is it not good enough, right? So we'll do a few things, but we'll check the accuracy of this, right? So we're going to take the model that we built, and we are going to White thread is not defined. Okay. So it says that, again, reading this code is really easy. So y predictions is equal to model.predict on my test set. I calculate accuracy by saying, is my predicted equal to test value and divided by total number of test cases. So it says it's 87% accurate. So the question is 87% accuracy a good thing, right? And then on the surface of it, this seems like a good thing, but you have to be very careful. Notice that in this data set, bad loans are only 13% of this data set. So it could be that it's predicting every single good loan as a good loan and it's missing every single bad loan, right? So just the number of 87% accuracy or 90%. I mean, think of a case of, cancer, right? So less than 3% or 2% of the population has cancer, or 1%, right? So saying that I built a 96% accurate model is useless. Accuracy is not a good metric. Anyway, so the reason, so what do? We look at something called a confusion matrix. Confusion matrix is, and I will switch to the slide, and you guys please let me know when the slides are visible. We are on a slide called train and test. So
yeah, we are there.
All right. So here is the confusion matrix that we just printed, right? So here's what it has done. It says actual good loans. I have about 6297 good loans. Okay, the sum of these two. It's predicted. Well, this is wrong. So prediction equal to good. So it's these two should be swapped. And it is for this,
And can you just repeat the last 10 seconds what you said? We couldn't hear you.
Don't want to confuse.
Hey, Anand, now we can hear you. We couldn't hear for the last 10-15 seconds.
Okay, what I was saying was are you able to see my PowerPoint now?
Yes, I can. Yes.
I just need to switch this. Okay. So it has taken out of 957. It's predicted that 938 of the bad loans are actually good loans. So it's only been able to identify 29 of the bad loans as actually bad loans. Okay, so not a very good first model, right? But that's how model building goes. You have to start somewhere, and you improve your model slowly. Okay, I'm back to the notebook. Can you guys see my notebook?
Yes.
Okay, so the model assumed a 50% cutoff in probability. So if it first calculates probability and it says if the probability is less than 50%, I'm going to say it's a good loan. If not, it's a bad loan. So what if we raise this probability to 70%? Will it make a difference? So we have to be very careful what it does, right? This confusion matrix will tell us. So it's gotten worse. So out of the bad loans, now it's only able to predict 8 bad loans as bad loans. So it's even worse. Okay. So let's go the other way around. Let's say, let's use probability threshold of 0.1, which is 10%. And now we see that it's classifying 743 bad loans as bad loans. But on the other hand, now it's also saying that about 3,000 of the good loans are bad loans. So, if you're starting to wonder, hey, we went through a lot of effort, we built a model, and it didn't really do a great job, that's okay. That's where we start. We've used only about 15, 16 columns. Those may not be the right columns. We have to keep repeating this exercise until, you have large numbers in these diagonals, right? So I'm calling a good value and if the actual value is actually good, I'm predicting it to be good, and the value is bad, I'm predicting it to be bad, and the rest of them are zeros. So one visual tool for doing this is something called an ROC curve. An ROC curve will give you a graphical sense of how good the model is. Okay, and in this case, you may think the model is bad, but it's not so bad. I mean, this would be a random model. This is starting to look like, you have some predictive power. It's not great, but a fantastic model would be like that. It'll look like a right angle, right? So, but we'll have to get more into ROC curves and things like that. But this is all you have to do is plot the ROC curve. If you see the bulge being more and more to your left side, then your model is getting better. There are many metrics to look at. You can look at them as well. Okay. Again, we're really short on time. Let's now talk about how do you deploy this model. Let's say that this was an acceptable model. Right? That's fine. How do you deploy it? Okay. So let's choose one of the cases. So I just picked one of the cases at random from our loan data set. So this could be, someone like me, going in for a loan, and the company that's giving me a loan has all this information about me before they issue the loan. Okay. It's very important now. And so the task for the bank or the credit card company or whoever is to now take this information and make a decision on, should I be given a loan or not? Okay. So the way we do that is we have to repeat the same transformations that we did with that data before we fed it to the model. So we just repeat that quickly. It's called pre-processing, and then we can run a prediction on it. And it says, well, yeah, this is 0, meaning it's not a bad loan. Go ahead and issue a loan to this guy. If you actually want to look at the probability, so it basically says, wow, this guy is really, really good. The probability of him defaulting is 8 into 10 to the power minus 5, is a very, very safe bet. Go ahead and give him a loan. All right, so that concludes our notebook walkthrough. Apologize for this running a lot longer than we thought, and for some of the technical difficulties, but if people have any questions, we can take them now.
Sure. So Anand, first, thanks a lot. I know we did have a little bit of technical glitch, but thanks a lot for making it relevant for the audience. There were some questions, probably fundamental questions. So a lot of questions were around the fact that what is the difference between machine learning algorithm and a typical analytics algorithm? At what stage do we say that this is machine learning versus that is non-machine learning?
Okay, so I'll give you my opinion on this, and people may differ. People may differ on this answer. It's a good question. Traditional tools for analysis like regression, logistic regression, linear logistic regression, decision trees, and so on. These are the traditional, what I would call as traditional analytics, or I would call them traditional machine learning algorithms. What a lot of the newer data scientists, or the new age data scientists, if you will, deep learning, those kind of things, they would call as true machine learning solutions, because we don't assume any structure to or a functional form ahead of time. But the distinction, really, to answer the question, right, the distinction is really not a very hard and fast distinction.
Okay.
One thing to keep in mind is machine learning now involves a lot more computational algorithms and models, like random forest, extremely randomized trees, things which are not your regular statistical models. So I mean, all of these models are statistical models. Don't get me wrong, but they're not your traditional statistical models. So that's the only distinction that I personally see.
Okay. Good answer. Um, Another question that some of the folks had, that if they could get the codes that you were using in Jupyter.
Yeah, I can put it on GitHub and give a link.
Sure,
Yeah, I
sure.
can do that.
That will be great. Um, and there was this question about what is TensorFlow. Someone asked,
Mm-hmm.
what is
Yeah.
TensorFlow?
So TensorFlow is a library that Google has released. It is accessible from Python, and it's really a library for deep learning. You can also use TensorFlow for credit scoring models, regression models, classification. That's a recent improvement or recent feature that they've introduced. So yeah, it's another library like scikit-learn. It's very strong on the neural network side. It's not as strong on the traditional model side. For example, I don't think they have clustering algorithms in TensorFlow. So its focus is mainly neural networks.
Okay. One question was regarding career. Someone has asked as to, after let's say learning machine learning algorithm. What is a better path to choose career wise? Deep learning, or probably more traditional, integration with big data, large volume data, and doing normal algorithm analysis. So what is a bigger and what is a better career path?
Again, I'll give my opinion on this, right? So I come more from the analytics side. I'm not from the software or technology side. So I recently attended this NASCOM conference on big data and artificial intelligence a few days back. The global demand for data science professionals is about 400,000, 4 lakh people, and the actual number of people they have is around 120, or also 120,000, which is 1.2 lakh. So there is a gap of about 2.8 lakh people today, as it stands today. A lot of this is because it's not that we don't have people; we don't have the right people or qualified people. So uh, my response would be, pick something and do it well, rather than, I mean, it's good to have understanding of all of it, but it's not humanly possible to learn everything. So if you want to learn traditional machine learning, pick that and do a very good job of that. If you want to learn deep learning, which seems to be something that everybody's talking about nowadays, pick that and just go deep into it. Don't stay at the surface, is what I would say.
Okay, good question. One more question was, while deciding upon the number of parameters, um, sorry, uh,
Mhm.
just sorry, I missed that question. While deciding upon the number of parameters to be considered while modeling, could we use scale deviance to determine the parameters, or we simply use trial and error method based on experience?
Well, so first, I don't have expertise in the scale deviance method,
Okay.
but I'll tell you how we do it, right? So there are techniques within each of these models called regularization techniques. So if you throw in 1,000 variables into the model will not take all 1,000. There are ways in which the model can keep the important few and take out the unimportant many, and maybe scale deviance is one of them. But when we talk about logistic regression models, we can use some kind of regularization, like an L1 or an L2 regularization is what they call it, to arrive on that same answer that you are alluding to. So yeah, it's not a pure trial and error. There are more scientific ways, like using regularization to do it.
All right. And I think since we are already over time, so I'm just going to ask one last question on the from the interest of most of the audience, most of the people who are attending the session. So Anand, since you have so many years of experience, so in terms of one strong career advice, if you would want to give someone who's trying to make a career in data science or analytics or machine learning or big data, so what would be that one-liner advice to the young folks? Because we have got people who are engineers, people who are from science, economics, mathematics background, or just general
Yeah.
MBA from a good college. So what advice would you give to them?
The one sentence, what I have learned personally, right, to pick one ecosystem and stick to it. Okay, what I mean by that is pick Python, pick R, pick Java, pick C, whatever it is. I mean, if you ask me, I think there are only two real choices, Python and R. But again, my point maybe my view may be a little jaded. So pick one ecosystem and stick to it, because you really need you really need to learn it well and learn it deep. Staying on the surface will really not do you any good. There are a lot of visual packages that people can use to do better than what you can. So pick one thing, pick Python, pick R, pick one ecosystem, and really go deep into it, really understand it well. And it'll take some time to do it, but you'll be very well rewarded for it.
All right. Thanks a lot, Anand. Thank you. Thank you, everyone. Thank you for joining in, Anand. Thanks a lot for all the wisdom that you gave today. I know it took a little bit of time and there were some small technical glitches, but still, I enjoyed the session, and I'm, looking at the messages that we're getting. So I think a lot of people enjoyed the session. I know a lot of people couldn't join. There were more than 500 registration for this webinar. Unfortunately, this particular tool allows us only 50 seater. Probably next time we'll actually go for a different tool which allows us more seats. But Anand, thanks a lot. I know it's evening, and and it's a weekday evening, so I'm sure you must have had some schedule as well. So thanks a lot for taking out time, Anand.
No, no, thanks, Pratik, and thanks all the participants for your patience. And
Sure.
I'm truly happy to do this. Thank you.
Right. And hey, guys, I know some of you have dropped by, but people who are there, check out Anand's company. He's one of the co-founders of a company called as Hypercube Analytics. They're doing great job. So just Google on them and see, what kind of job what kind of work they're doing, and try to explore and probably learn something as to what exactly these guys are doing. Um, Thank you. Thank you, everyone. Thank you, Anand.
Thank you all. Bye.
Thank
Thanks,
you.
Pratik. Bye.
Bye bye. And guys who are looking for codes, so we'll send out an information on how you can get the codes probably in a couple of days. Thank you, everyone.